For our case study, we took apart a 2-slice toaster and labeled the manufacturing processes that were used to make the key components. The manufacturing process that was used to make the plastic parts of our product is injection molding. Injection molding was best for making all of these parts because this process is good for making detailed parts and parts with thin walls, and it has a high production rate. Our first component is the case for the toaster. This was probably made by injection molding with a complex die. We think this because you can see the parting lines inside of the component. There is also a small hole in the part which is due to the lack of material used during injection molding. The next component is the bottom tray. We know this part was injection molded because we can see the places where the ejector pins push the part out of the mold. The following 3 components are the knob, tray handle, and lever. The ejector pin marks from the injection molding can be seen on each of these parts.
The following components are made from sheet metal that was stamped and bent into the desired shapes. Some internal components of the toaster include the walls and the base plate. These components were manufactured using sheet metal that was stamped, then bent into the proper configurations. On the base plate, it suggests that a progressive die was used in the manufacturing process due to the surface protrusion located in the middle of the part.
The toaster lid is made from stainless steel sheet metal, and evidence suggests that a progressive die was used to manufacture the component. The progressive die used to make this part used a combination of shearing, bending, and stamping operations. The first step in the conveyor was the punching of the slots and the tabs. The steps following the punching consisted of several bending processes that occurred along the conveyor. Due to the complexity of the bending, there is a chance that a transfer die process was used to manufacture the lid. However, a progressive die is the most efficient method due to its higher production rate.
Next, we will talk about the grill, which was manufactured using a series of processes. The rods for the grill were most likely made using the cold extrusion process due to the surface finish of the steel. An alternative to this process would be drying. The rods were most likely bent using compressive bending. Finally, the joints of the wires were connected using crosswire welding, a form of solid-state resistance welding. Crosswire welding works for this application because multiple welds can be completed at once.
The mica sheets and nichrome wire are contained in the following assembly. This assembly creates the heating element for the toaster. The mica sheets are stamped using a vacuum and a hydraulic press and later chemically treated. Once the mica sheets are completed, the nichrome wire is wrapped around the mica sheet. The nichrome wire is created via the drawing process. The nichrome wire could also be extruded. However, extrusion is used for more complex and larger components.
The circuit board is soldered using the wave soldering technique. The lack of solder on top side of the board and the abundance of solder flags are typical features of wave soldering. Reflow soldering is a competing process to wave soldering. However, reflow soldering is typically used to solder sensitive microchips and also consumes more time per operation when compared to wave soldering.
GD&T is important for guaranteeing a successful mate between components of an assembly. In the case of the temperature control knob, the size of the central bore must fall within the specified tolerance zone. Otherwise, the central bore would not mate with the potentiometer. It is possible that if the central bore is too small, the plastic will crack. Also, if it is too big, it will not control the potentiometer.